Hello, we have just derived all the formula, which are, well, I cannot say all the formula, but many of the formula that are needed for your future mathematical experience. And one of the kind of questions that I have assigned in your homework is that reduce the power of a trig function. Okay, so I'm going to use some examples to explain to you. For example, okay, if you look at one of the homework questions, okay, so let me make this a homework guide. One of the questions is to reduce power, right? For example, we have sine squared of x, right? The power of this expression is 2. We want to reduce the power to 1 or 0, right? So we basically want to rewrite this expression in a different form. And this kind of question is typically needed. Well, you will encounter this necessity in calculus 2. Okay, because after the reduction, you will be able to, complete the integration. In this particular case, right, the relevant example would be one of these. Okay, from double angle formula, we derived that cosine squared equals to 1 plus cosine 2 alpha divided by 2. In this case, the power has been reduced from 2 to 1. For sine square alpha, the power was 2. Now the power is reduced to 1 or 0. Okay, so in this case, this formula would be relevant. Okay, so this formula would be relevant. Okay, so we apply this formula. And when applying this formula, of course, we have x here, and there we have alpha. So replace alpha by x. And we can use either one of the form. Okay, so the final answer would be that. Okay, and in this final answer, you can see the power has been reduced from 2 to 1, right? So this power cosine, to the power of 1. So from power 2 to power 1. And here there's a constant part, of course, that's power 0. So that's one of the examples, right? And of course, for number 2 on the homework, it's asking to reduce power. And you can see the relevant formula would be this one. Okay, and in which case alpha is turning to x, 2 times x and 2 times x. Okay, so we can use any one. You can use any one of the form. You really can use any one of the form. Okay, this form I used here it looks more balanced. Okay, so but question could get a little bit more complicated. Right? Question could get a little bit more complicated. So let me show you number 3. Okay, just a little bit complicated. So we have sine to the power squared of 8x. So we want to reduce the power. So of course, once again, this formula would apply. Right? But in this case, at the place of alpha, that's 8x. So alpha will be replaced by 8x. Okay, so alpha will be replaced by 8x. Right, so this is going to be 16x. And of course, here it's going to be 16x. Okay, so that's the reduction. That's the reduction in power. Right? So Now let's look at a bit more complicated situation, right? So here I'm selecting number 4. Okay, so I'm just going by the order of the text of the homework question. So this time is sine to the power 2. Instead of the 2, we have 4, power 4 x. And we want to reduce power, right? We want to reduce the power to 1 or less, or 0, okay? We wouldn't want to have less than 0, right? We're gonna have reduce the power in the entire expression into power 1 or 0. Okay, so the result will be similar to something like that. Of course, in this case, it's going to be way more complicated. Okay, but algebraically, certainly is doable, right? So this will take multiple steps. Okay, and so I'm going to show you the steps. Okay. First of all, we understand the notation, right? This is the same as sine x multiply sine x, right? Multiply sine x 4 times, right? 4 times. So we understand that. And as a result, we know that this is going to be sine of square x to the power 2. Okay, and the inside of this sine squared of x can be replaced by one of these, right? Which we did earlier, right? Sine square of x equals to this guy. So that will have the reduction of power. So we're gradually reducing the power. Okay, we're gonna gradually reducing the power. So this is the inside the parentheses will be replaced by that, right? So the outside is still squared. So now the power has been significantly reduced, right? Because the inside the power has been reduced to 1. So when we square it, now the entire thing, the power is 2. So power has been reduced from 4 to 2 now. So we need further reduction. To make further reduction, we're going to power the inside of the parentheses. So we're going to have 1/2 squared. Okay, be sure you have your notebook with you, okay? And this parentheses will be squared. Okay, so at this point, I wish to remind you of this formula. Okay, a minus b squared. So this is a, and that is a cosine 2x is a b. And that, if we FOIL, we get a squared minus 2ab plus b squared. Okay, so we're going to apply this formula to our case. Now, what do we get? Right? 1/2 squared is 1/4. Inside the parent, and this piece, I'm going to put it in a bracket. Okay, so a squared, which is 1 squared. Okay, this 1 squared, square can be omitted, right? So you can just write 1 minus 2ab, 2 times 1 times cosine 2x. Okay, plus b squared. So cosine 2x times cosine 2x, that's going to be cosine square of 2x. All right. So now the power is not reduced, okay, because from here, the power is 2, we still have power 2. But we are breaking it down, okay? If we organize the term here, right? 1 squared is 1. 2 times 1 times cosine 2 squared, that's a 2 times cosine squared. So this is already power 1, power 0, right? So we're done with these two pieces. We just have to reduce power for this guy. And in this case, we can apply this formula, right? We can apply this formula. So next step, we're going to apply that formula. Okay, so we're going to apply that formula. And in our case, 2x is in the place of alpha, so 2x. So alpha will be replaced by 2x. 2x, and that makes 4x. And alpha, 2 alpha is now 4x. You see, that's just a series of substitution. Now we're going to bring that in, right? We're going to bring that in, and we're going to replace this guy by its equal. Okay, cosine squared 2x, right? You either do this piece or you do that piece. It doesn't matter which one you use. Okay, so I'm going to use this one for a change to replace by its equal. All right. So the next step is that we have a denominator here. So I'm going to make a common denominator on all of these parts, or I'm going to bring this denominator outside the bracket. Okay, so what I would do is that I'm going to multiply, right? Here, I'm going to multiply a 2 over 2. 2 over 2, right? It has a denominator. And 1 is equals to 2 over 2, right? So that way, the 2, 2, 2, they are the same denominator. With that as our common denominator, so we're going to take that common denominator outside. So 1 over 4 multiply 1 over 2. Whoops. Okay, 1/2. Okay, so we still have that bracket. And half, this denominator is out. So we have a 2 here from here. And in this case, right, it's minus. The denominator 2 is out, so 2 times 2, that's a 4. 4 times cosine 2x. Plus, on this piece, the denominator 2 is out, so we're going to have 1 plus cosine 4x. So now everything, we don't see power 2 anymore. So we are almost done. Okay, we just have to organize the terms. Okay, quarter times half, that's 1/8. Okay, that's 1/8. Inside the bracket, 1 and 2, that makes 3. And in the end, we have 8 multiply 3 minus 4 times cosine 2x plus cosine 2x. Okay. If you want to change this to parentheses, which makes no difference, you could. Okay, I put the brackets here just in case I need to insert, parentheses. But in the end, it's the same thing. Okay, so this is the whole process of reducing power. If we have something like this, right? You would have to go through multiple steps to do that. Some typical situation that you have to do this is it's in Calc 2, okay, integration. So let's try one more. Which is number 5. Okay, so I hope you guys will do this along my side, okay? Do it with me. So cosine to the power of 4 of x, okay? It's very similar to what we did. So if you like to pause, right, to pause this and just do it and then come back to compare with me, that would be amazing. Okay. Once again, notation-wise, make sure you understand the notation, okay? So we have a cosine square of x, and x, you know, that square outside. And then we do the substitution inside the parentheses, right? Inside the parentheses, cosine square alpha. Here we have x, right? So we're going to apply this formula. We apply that, right? So here's x, right? And then you can use either one. So I'm going to use this one, right? So in the next step, the inside of the inside will be replaced by this piece. And then the outside, it's going to be squared. And then similar to what we did earlier in the previous question, we have a quarter, right? Parentheses. And this time is 1 plus cosine 2x squared. We just have to use a different formula here, okay? So what will be that formula? That formula is a plus b squared. Okay, so a plus b squared equals to a squared, if you FOIL that, plus 2ab plus b squared. You can see these formula that you learned in elementary algebra. They're often used. They're often used. Equals to, so now we're going to apply the formula, right? So quarter parentheses. So I have 1 squared is 1 plus 2 times 1 times cosine 2x, 1 plus cosine square of 2x. And the rest of the substitution actually is very similar to what we did on the previous question, okay? So let's continue. This is going to be a quarter, right? And once again, we're going to replace cosine squared of 2x, right? So this was a cosine x. So now we're going to do a cosine 2x. So we're still going to apply that same, okay, the same formula, but a slightly different symbols, okay, because of cosine squared 2x. So the alpha is replaced by 2x. So alpha replaced by 2x. So 2 times 2x, that's a 4x. So 4x here. So repetitive use of the same formula, right? So now we're going to put this in. So 1 plus 2 times cosine 2x plus, okay, this piece can be replaced by that totally. You can write it down the other one too. Okay, no, there's just a personal preference, okay, personal preference. So these things that I put in the bracket, you don't have to write them down when you show work. I'm putting it here because I'm explaining to an audience. Okay, so 1/4. So once again, we're going to make a common denominator because we want to factor out the 2. Okay, so we're going to multiply 2 over 2, that's a 1, okay? And this 1, you can write it as 1 multiply 2 over 2. This is just to get the common denominator, okay? So at this point, we can factor out the half, right? The denominator 2, and the outside will be 8, right? So this will be, so this whole thing, if I take out the 2, this becomes 8. And this is going to be 2. And that's going to be 4, right? And this 2 will be gone, right? So in the end, on this piece, we really just have 1 plus cosine 4x. And the next step, we're gonna have 1/8, right? We just combine some like terms. We still have 1/8. 2 and 1, it will combine. That makes 3. There, okay? So finally, power is reduced. This is power 1, power 1, power 0. So now we have power 1 or 0. Okay, so let's look at another example. This one, number 9. Number 9, we have sine square of x multiply cosine square of x. There are certainly multiple ways to do it. There are multiple ways to do it. If we keep using these two formula, we can certainly do that, okay? But I would introduce you other ways because we want you to get familiar with all of these formula by using them over and over again, right? So you don't have to make great effort to memorize. So that's the goal. So for this one, I want you guys to follow, practice, and try again on your own because this will greatly enhance your algebraic skill, which you really, really need. Right, so on this one, I'm going to show you multiple ways of doing it. Okay, suppose that we're stuck up with these two formula, right? So we're going to replace sine squared by its equal, right? So cosine, we're going to use this formula. So we apply both. Okay, we apply both. So we just put next to it. Okay, we apply both. And of course, that's x, 2 times x, 2 times x. So this is x. And so this is going to be 2 times x, 2 times x. Okay, so we're going to multiply these two. It doesn't matter which one you use, really. So that equals to cosine squared replaced by that. Sine squared will be replaced by this guy, right? So we just multiply the two. And next, we got half times half, that's a quarter. Then we got 1 minus cosine 2x multiply 1 plus cosine 2x. So now we have from power 4, now it's power 2. And here we got to use another special formula, okay, which is a minus b times a plus b. If we FOIL these, we're going to get a squared, not 1, sorry, minus b squared. Okay, so we're going to apply this formula. Apply. Okay, so here we go. Continue. We have a quarter. And inside the parentheses, it's going to be 1 squared minus cosine squared of 2x. And then we're going to reduce the power for this piece. The power for that piece equals 2. Okay. We've seen cosine squared 2x before, right? So we can just reduce it, right? We're going to apply this piece, right? We're going to apply that piece. You can see it's full of substitution. So this is going to be 2x. Or maybe I use this guy so we don't get confused by x, right? So alpha is 2x, so 2x here. So this is a 4x, right? So this is a 4x, right? So we're gonna replace this piece by one of these, right? We just take this one, take that one. Boom. And then common denominator, right? So we're gonna rewrite 1 as 2 over 2. 2 over 2. So 2 is factored out, and we will have 1/8 multiply 2 minus this piece. Okay, be careful. I'm going to keep it in the parentheses for the moment. Okay, so the outside, I'm going to use a bracket. Okay, because this is subtraction, it's subtracting the entirety of this fraction. When the 2 is out in the denominator, which is factored out, we have 1 plus 4x. So subtracting the entire thing in the parentheses. Be careful, because this is a place we can make a minor mistake, right? All right, so near the end, we get a 1/8 parentheses. If I open up the parentheses, I have 2 minus 1 minus cosine 4x. And there we go. There we go, right? So we will have this piece, this makes 1. Okay, we don't need another step. Okay, so that's reduced. I promise that I will show you another way. Yes, I will. Okay, I'm going to show you another way, because this will allow us to employ another formula. Okay, so I'm going to show you another way, right? In this kind of questions, there are multiple formula may be needed. Okay, multiple formula may be needed. So I'm going to show you another formula. Okay, this other formula is sine of 2x, double angle for sine. So the way I'm writing it, I'm going to write it as sine x cosine x. I put the power outside. Okay, so here we have a formula. This is the formula. Okay, sine of 2 times alpha is equals to 2 times sine alpha multiply cosine alpha. Okay, so in our case, if we employ this formula, okay, we get to use this formula. Sine of 2x will equal to 2 times sine x times cosine x. So if we divide both sides by 2 from here, we will get a sine x times cosine x equals to half of the sine of 2x. Okay, so we're going to replace sine x times cosine x, which is inside of it, by the reduced power, right? Because this has a power 2. And now when we replace it by half of sine 2x, that's power 1. So we replace it by the lower power, okay? Watch the algebraic manipulation. Okay, we all need to enhance our algebraic proficiency. Okay, so derive as much as you can. So square, so we're gonna get half of sine square of x. So this is sine square of x. And the rest is similar to what we did earlier, except in this case, we're gonna substitute by this formula. Okay, so if we apply this piece, right? Sine square of 2x. So this alpha becomes 2x. So this is 4x. And that's 4x, right? So by this time, you probably is very familiar with it. So 1/2, oh wait, 1/2 squared is a quarter, my bad, quarter. Okay, quarter. And sine square of 2x, you're gonna replace by one of these. So we're gonna just substitute, put that in, okay? And in the end, we get 1/8 multiplied by whichever one is easier, it's your judgment. Okay, you can compare. I think the latter one is a bit easier. It's a bit easier. Okay. Number 10 and number 11. I'm going to do number 10 to show you that we need to employ other formula. Okay, there are also multiple ways to do it. And in this case, in this situation, right? So I'm putting these formulas still with here, and I have all the formulas, okay, down below, right? And you have the diagram. You have the diagram. Of course, I have the diagram too. But in terms of reducing power, so we have sine of 2 pi x multiply cosine of 5 pi x. The idea is to reduce power. So because so far as what's given, the power is 2. There's a power 1 here, right? Power 1 here, there's another power 1, and we multiply that as a power 2. So we want to reduce power 1 or 0, right? Apparently these formula no longer apply, right? So what formula will reduce the power? So that seemed to be the formula that would transform product into sum or difference, right? Into sum or difference. We have derived those expressions, right? So one of these, right? You see, this is power 2, power 1, power 1, power 2, power 1, power 1, power 2, power 1, power 1. So not one of these, one of these. So I'm going to bring these forward, and we decide which one shall we use. Which one does it apply? Sine times cosine. Sine times cosine is right here, right? So we would apply this formula. Okay, can we apply this piece? Of course you can, right? Of course you can. You just have to, shuffle the place, right? It doesn't really matter. So let's just use this one. So we're gonna apply this formula right here. And our A is 2 pi x, right? A is 2 pi x. 2 pi x. So A is what? 2 pi x. B, A is 2 pi x. 2 pi x. Everywhere A was 2 pi x. B is 5 pi x. 5 pi x. 5 pi x. Okay, so now cosine or sine 2 pi x cosine 5 pi x, we could just replace it by the whole thing. Power is already reduced. The rest is just simplifying. Okay, the rest is just simplifying. To simplify, we got just to add up the quantities in the parentheses. 2 pi x plus 5 pi x, that's going to be 7 pi x, right? And we don't need the parentheses anymore. And this piece is a negative 3 pi x. So this is a negative 3 pi x. Well, sine is an odd function, right? So we can reduce it further, right? So we can reduce further. And so now we have half. Oops, half. Inside the parentheses, we have sine of 7 pi x. And the odd function, so that's going to be make it sine, negative sine of 3 pi x. Done, right? So here I'm going to put a note that sine is sine function is odd, right? So that means sine of the opposite input produces the opposite output. Odd function. That's it. Okay. So that's you can see we have variety. So sometime on one of these formula will be used. Okay, I'm going to save number 11 for you, and we're going to move in towards number 12. Number 12. 12. This will take even more steps. So we'll try to see how I can, how we can get it done more effectively and quickly. And sine to the power of 4x. There's certainly multiple ways to handle this. Okay, whoops. Cosine square x times sine to the power of 4x, right? Excuse me. So what you can do, there's so many ways. So I'm just going to pick up one way, right? So what I'm going to do is I'm going to keep the cosine square. And I'm going to break this up to sine square square of x and multiply sine square of x. Okay. So we're going to bring these two together. Okay, these two together. And that will make sine x cosine x and then squared, right? And the next one, of course, we have sine squared outside, sine square of x outside. And then we're going to use the double angle for sine, right? Remember we did this before, right? So I'm going to apply that. I'm going to apply that to 2x, right? So this piece is going to be the inside the parentheses will be replaced by half of sine of 2x, like that. And how about sine square x? Well, for sine square x, I'm going to use a double angle formula, but we're going to just do it just a little bit later, okay? Because we're going to do that substitution together. Equals to, so now we got a quarter sine square of 2x multiply sine square of x. So now we need a substitution. We need substitution for this piece and that piece. And guess which formula would apply? And of course, it's this one, right? Of course, it's this one. We just have to use it twice. We just have to use it twice. Okay, so we're going to apply that piece. Okay, the first time application is going to be for sine square 2x. Okay, so 2x, so this alpha is 2x. So this is a 4x. And that's 4x. Right, so we're going to take that piece and put it right there. Okay, cosine square of x, well, it's just, we just use this formula, replace it once, right? Alpha turn into x. We've done this so many times, right? We've done this so many times. Just be patient with ourselves, right? So we're gonna multiply this piece with that and put it in place. It looks like we have to do it one more time, right? We have to do it one more time. So quarter, half, half. So now we have accumulated some interesting factors. So that's 1/16. Make sure we get that right. So we get this piece and we get that piece. And we're going to have to FOIL. We're still not quite, we haven't get to the last part because we still have power 2, right? But this time we're going to FOIL. Okay, so 1/16. We're going to FOIL 1 times 1, that's 1. 1 times cosine 2x, that's minus cosine 2x. And negative cosine 4x times 1, that's a cosine 4x. And plus, finally, cosine 4x multiply cosine 2x. There we go. Power 0, power 1, power 1. So all these are done. We just have this piece left. We just have this one piece left, right? And then we will need to replace it by which formula? Product to sum or difference. It looks like this piece is going to be most fitting, right? So we're going to apply that formula, right? So A is 4x. So everywhere everywhere A will be replaced by 4x. B is 2x. Everywhere B replaced by 2x. Boom. There, right? And we're going to take what equals to this piece, which has been reduced to power, right? Which has been reduced power, and we're going to replace it right here. Okay. So now there's a little unit here, which used to be cosine 4x times cosine 2x. And there's a big parentheses outside. And of course, we're going to reduce it, right? We're going to reduce it. We're going to organize the term a little bit. So this will make 6x, right? And this makes 2x. And there we go, right? And we have a denominator too. So we're going to make a common denominator. So that's 2/2. So that makes another 2/2. And this will make another 2/2. So now the common denominator, right? The common denominator is 2. So we take out the 2, 2, 2, all these common denominators taken out. So we get a 1/32 inside the parentheses, right? So this piece becomes 2 and minus 2 times cosine 2x, right? Over here, we minus 2 times cosine 4x, right? Because all of these 2's are factored out. Now it comes to this piece. So we have cosine 6x plus a cosine 2x. So we have a cosine 6x plus cosine 2x. Okay, so our patience has been paid off. It's been paid off. And that equals to 1/32. I'm going to organize the term inside here. Okay, do we have any like terms? So that's the question, right? Cosine 6x cosine 4x alone, cosine 2x, and this is negative 2 cosine 2x. And there's only one constant. So we're going to have 1. This is negative 2 cosine 2x. This is a positive cosine 2x. So we have 1 cosine 2x left. And the rest, they're standing alone. No more like terms. That's it. So that's finished. Okay. So here goes the, the first set of, the first question on the homework, how to do it. And the application, right? The application, you will actually use it in Calc 2, in integration. Okay. And the tools we're using, are primarily transforming product to sum or difference or double angle formula, which is all reducing power. Okay, because if you look at all these formula, right, they reduce power. So that's all for this lesson. Thank you for watching. See you next time.